Welcome back to my YouTube channel. So for today's video, we're now going to answer all of the activities included in chapter 7. So without further ado, let's start. So as you can see, we are now here in the first activity in chapter 7. And this activity is entitled the binary to decimal conversion activity. And the instructions, it is said that this activity allows you to practice 8-bit binary to decimal conversion as much as necessary. We recommend that you work with this tool until you are able to do the conversion without error. Convert the binary number shown in the octet to its decimal value. So as you can see, the base, the exponent, the position, and the bit are already given, and we're just going to answer the decimal value of it. So for us to answer this activity, so as you can see, there have many different kind of position, and some of position have 0 bit and some of those have 1 bit. So for you to get the decimal value here, you're just going to add the position that having 1 bit or the 1 value under those numbers in position, like 16 having 1 bit, 4 in 1 bit, and 2 with 1 bit, and 1 with 1 bit. So we're just going to add those position to get the decimal value. So 16 plus 4 is equals to 20, and 20 plus 2 is equals to 22, and 22 plus 1 is equal to 23. So 23. So as you can see, it's stated that the decimal value you have entered is correct. Please click new number to continue. So there we go. There is a new set of a decimal to be answered. So the position having a value or a bit is number 32, 16, 8, 4, and 1. So let's start. So 32 plus 16 is equals to 48, and 48 plus 8 is equals to 56, and 56 plus 4 is equals to 60, and 60 plus 1 is equals to 61. So just click the check button. So correct. And we're now going to proceed to the next activity in this chapter. So in this second activity in this chapter entitled the decimal to binary conversion activity, so as you can see, this activity is the opposite of the activity in the first activity in this chapter, which is the binary to decimal conversion, and this one is the decimal to binary conversion activity. And the instructions, it is said that this activity allows you to practice decimal conversion to 8-bit binary values. We recommend that you work with this tool until you are able to do the conversions without error. Convert the decimal number shown in the decimal value row to its binary bits. So as you can see, the decimal value is now already given, and the bit is now we're now going to give the answer. So for you to answer this, the decimal value will be subtracted by the position. If the decimal value can be subtracted by the position, then the value of bit will be going to be 1, and if the decimal value cannot be subtracted by the position, the value or the answer in the bit will be 0. So let's start. 195 can be subtracted by 128. Yes, so this bit can be answered by 1. And the second one is, and 195 minus 128 is equals to 67. So 67 can be subtracted by 64. Yes, so this bit has 1. And 67 minus 64 is equals to 3, which 3 is cannot be subtracted by 32, 16, 8, and 4. So this position is all 0. And all of these are 0. So, and 3 is now can be subtracted by 2, which having an answer 1. So this bit will be going to be 1, and 1 minus 1 can be and 1 can be subtracted by 1. So as you can see, so for you to get the decimal value, the bit that having a 1 value in the position, like 128 plus 64 plus 2 plus 1, if we check this answer, the addition of this all of those position will be the total of 195. So let's check this first. Just click the check button. Check. So as you can see in the lower part, the binary values you have entered for all positions are all correct, and please click new number to continue. So let's click the new number, which is 206. So 206, same procedure. So 206 can be subtracted by 128. Yes, so this is 1, and 206 minus 128 is equals to 78, and 78 can be subtracted by 64. This is also 1, and 74 minus 64 is equals to 14, and which is number 32, and number 16, or the position 32 or 16 cannot be subtracted by number 14. So these two will be going to be 0. And now the 14 can be subtracted by number 8, so it will be going to be 1, and 14 minus 8 is equals to 6, so 6 can be subtracted by 4, and this will be going to be 1, and 6 minus 4 is equals to 2, and 2 minus 2 is equals to 0. So the answer is already 0, so the number 1 is going to be number 0. So as you can see, we're done, and for you to get the answer of 206, you're just going to add the 128 plus 64 plus 8 plus 4 plus 2 is equals to 206. So let's check this. Just click the check button. So there we go. As you can see, my answer is now are all correct. So let's proceed to the next one. So in this activity, the activity entitled the ending to determine the network address, and the instructions, it is said that use the ending process to determine the network address in binary and decimal formats. So as you can see, the host address are given, subnet mask are given, host address in binary are given, and the subnet mask in binary are given. So we're going to answer the network address in binary and the network address in decimal. So for you to get the answer in the network address in binary, we're just going to compare the host address in binary and the subnet mask in binary. And for you to answer this, if there is one answer that is false, or zero value in subnet mask in binary, and if the host address in binary have 1 value and the subnet mask in binary has 0 value, then it is false. But if the host address in binary have value 1 and the subnet mask in binary have a value 1, then it will be going to be true. We're going to indicate that number. So let's start. So as you can see, the 40 and the 41 in subnet mask in binary are not the same, so this will be going to have a 40. Then 1010, and the next one is 0. 0 0, false false, false false false, true, false false, true, and false. And this one is false, true, 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 false, true, true, false. And the last one is, and these ones are all false, having 8 here. 1 2 3 4 5 6 7 8. So for you to get the network address in decimal, you're just going to substitute the network address in binary into network address in decimal. So we already know that the total of this 8 address is 255, and let's start counting in the right side. So 0 1 0 1, and it is equivalent to number 10, because the first 0 is the 1 2 4 8, and so 8 plus 2 is equals to 10. And the next one is 1 2 4 8 16, so 16 plus 2 is equals to 18. And this one is 1 2 4 8 16 32 64, so 64 plus 32 plus 16 plus 4 plus 2 is equals to 118. And this one is all 0. So just click the check button. So as you can see, my answer in these activities are all correct, and just click the new number to start a new. So it is have a same procedure. So it is 40, which is all false. 1 2 3 4, true, false, true, false. And this one is false, true, 3 zeros. 1 2 3, false, true, false, true. And this one is 3 false or 3 0, then true, false, and 3 true, or 3 1. And this one is false, true, true, false, false, oops, wrong, true, true, false, false, and false, false, false. 2 4 6 8. So for you to get the network address in decimal, we're just going to substitute again the network address in binary. So the substitute of this is 8 and 2. 8 plus 2 is equals to 10, and this one is 1 4, and 64 is equals to 69. And this one is 1 2 4 16 is equals to 23. And this one is 32 and 64, which is total of 96. 10 69 23 96. So just click the check button. So there we go. As you can see, my answer is also correct. So let's proceed to the next. So as you can see, we are now here in the fourth activity in chapter 7, entitled the unicast, broadcast, or the multicast. So in the instructions, it is said that click start to view the destination IP address. Next, click the host, which will receive a packet based on the address type, which are the unicast, broadcast, or multicast. This is a timed activity. So as you can see, in the right side, there is There is a time remaining 10 seconds for you to answer in this activity. So when you click the start, the destination IP address will be shown, and we're just going to click the host, which will receive a packet based on the address type. So let's start. So let's try again a new destination IP address. Click start again. So 192.168.100.5 is this one. So correct. You have successfully identified the transmission type. And the next one is 192.168.100.2 is this one. Only this one. So I have successfully identified again the transmission type. So in this activity, which is entitled the pass or block IPv4 address, the instruction said that decide to pass or block each IP address depending on whether it is a public, the Ethernet, or private small local network. Just click to start to begin and click on either pass or block. So let's start. This is pass, and this one is block. This one is also pass. This one is also block. And this one is pass. But yes, as you can see on the left side, correct, you have successfully identified public and private IP addresses. So I'm done deciding to pass or block each IP address depending on whether it is public or the private. So let's proceed to the next. So as you can see, this is the another activity in this chapter, and this activity is entitled the public or private IPv4 address. So as you can see, this activity is somehow same with the last activity, and this is in the instruction it is said that drag each IP address to the correct category, public or private. So in the last activity, we're just guessing which if it is a public or private, and in this activity we're just going to drag the IP addresses if it is public or the private. So 172.16.35.2 is, I think it is belongs in private, and 192.168.3.5 is also belongs in private, and the 192.0.3.15 belongs in public, and the next one is 64.104.0.22 belongs in public, and the next one is 209.165 201.30 belongs in public also, and the three remaining IP address are all belongs in private. Oops. So to give you a hint for answering this activity, in the private, all of the IP addresses starting with 172, 192, and 10 are all private addresses. So as you can see, the 172, 192, 172, 192, and 10 are all belongs in private, and in the public is the 192, 64.104, and 209 belongs in public. So let's check this first. So correct, you have correctly identified all the IP addresses. So let's proceed to the next. So in this activity entitled the IPv4 issue and solution, and the instruction said that drag the IPv4 and IPv6 terms to the field next to the appropriate description. So as you can see, there are 5 terms and 5 descriptions over here. So we're just going to drag this IPv4 IPv6 terms to the field next to the appropriate description. So let's start. 128-bit address, 340 undecillion addresses. Oh, it's the IPv6 or the IP version 6. If the version gets higher, the bits and the address and the undecillion address will get more higher. So the 32-bit address and the 4.3 billion addresses is the IPv4 or the IP version 4. So after the IPv4 and IPv6, it will now going to transport in IPv6 packet over IPv4 network. So from the word transports, it is the tunneling. So as you can see, there's some description having a clue or the hint that same with the term, so it is easy to answer this activity. And uses NAT64 to convert between IPv6 and IPv4, or to convert, from the word to convert is the translation, and to allows IPv4 and IPv6 to coexist on the same network segment, or on the same, from the word on the same network segment is the dual stack. So let's check this. Just click the check buttons. So there we go. I have successfully matched the IPv4 and IPv6 terms to their descriptions. So we're going to proceed to the next activity. So as you can see in this activity is entitled the Practicing IPv6 Address Representations, or the IP version 6 address representation. Instruction said that convert the IPv6 addresses into short, omit the leading zeros, and compress forms. Use the numbers at the bottom of the page to continue these activities. So as you can see, we have 10 figures here, and we're going to answer all of this. So in the preferred format, you can see the given and the omit leading zeros, and the compressed format is the two needed to be have an answer. So first is omit leading zeros. So from the word omit leading zeros, if you can see the leading number of zeros, you're going to omit that number. So let's start. So this will be going to be 2001, and this is 0. Omit the leading zeros, so this will be going to be DB8, and this one will be 111, and this one, and this one will be going to be 0, and this one also 0, and this one will be 200. So in compressed format, we're just going to compress this omit leading zeros. So to compress this, so there will be going to be 2001 colon, and then 0, then colon, and DB8, 0 colon, DB8 colon, and then 1 2 3 4, and then colon, and 2 colons, then 200. Then let's check. So let's proceed to the figure 2. So there we go. So first, omit again the leading zeros. 213, 0, 1 2 3 4 5 6 89 AB, then CDEF, capitalize CDEF, then 0, then 1. So we're now going to compress it. So this will be going to be 2013 colon, then 0 colon, then 1, 2, 3 colon, then 4, 5, 6 colon, and 89 AB colon, then CDEF colon, then double colon because it is 0 and last of the two leading 0, and this is 1. So let's check the compressed format. So it's stated also correct. So let's proceed to the figure 3. So as you can see, it is correct. Let's proceed to the figure 3. So there we go. As you can see, the preferred format and the first 1, 2, 3, 4, 5, 6, 7, 2, 4, 6, 7, and the first 7 preferred format is 0, and the last one is the leading is also 0. So these are all 0, 0, 0, also 0, 0, 0. So this one, and this is 1. So to compress this, so we're just going to omit the leading 0 again, and for substitute this into compressed format, it will be like double colon, then 1. So check. So as you can see, my answers are correct. So let's proceed to the figure 4. So there we go. This will be going to be 2012. And this one, A, B, C, D, E, F, O, 1, then 2, 3, 4, 5. Oh, omitting leading 0, so this will be going to be 6, 7, 8. Then this one is 9, 1, 0, and this is A, and this one is B, capitalize B, B, B. And then we're going to compress this one, 2012 colon, A, B, C, D, colon, E, F, O, 1, colon, and 2, 3, 4, 5, colon, then, 6, 7, 8, colon, then 9, 1, 0, colon, and 4A and colon, then 4B. 1, 2, 3, 4. So let's check. So there you go. It is also correct. So let's proceed to figure 5. So there we go. A, B, 1E, 2 It's not 28, it's 2B00. There we go. And then 0. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 0, 1, 1, 2, 3, 2, and 1, 1, 1, 3. And let's compress this for compress format. Then we'll be going to AB 1E colon 2B 00 2 colon because of the leading 0. Then 1, 2, 3, 4 colon. Then 5, 6, 7, 8 colon. Then 9, 1, 0, 1 colon. Then 1, 1, 1, 2 colon. Colon. Then 1, 1, 1, 3. Let's check. And so correct. So let's proceed to the figure 6. There we go. This will be BB 2B EF 12 B FF 3 91 25 111 1, and this is 101 1111, and this one is 101. So let's compress this, and this will be going to be BB 2B colon 1X EF 12 colon BFF 3 colon then 9125 colon 12341 colon then 101 colon then 1231 colon then 101. So let's check. So correct. So as you can see, these activities have a lot of figures. So we're now already in figure 6, and there were figure 7, figure 8, 9, and 10. These all figures have same procedure. So I was not able to answer all of these figures because this is so very difficult and very long method. So we're going to proceed to the next activity. So this is the last activity included in chapter 7. So activity entitled the Identify the IPv6. So instruction said that drag the IPv6 address type to the most appropriate description, 3 terms and 5 descriptions. So we're going to drag this first, excuse me. And this novel unicast. The first description is unique internet routable IPv6 address dynamic or static is the global unicast. FE802 colons 1 is the link local, and the 2001 colon DB8 colon ACAD double colon 1/64 is the global unicast, and the typical IPv6 prefix used to indicate the network portion of the address is the what we call the is the slash 64 and used to communicate with other devices on the same IPv6 subnet is the link local. So let's check. This. So just click the check button. So as you can see, correct, we have successfully matched the IPv6 address types to their description. So thank you for watching and bye.